episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Right. Well, welcome everybody again to another episode of our show with another truly fascinating guest helping to create a better tomorrow for all of us. Today, we are honored to be joined by Marwa ElDiwiny, who is a PhD researcher at Vrije University in Brussels, in the Faculty of Applied Sciences in the Department of Mechanical Engineering. Marwa works with the BruBotics group, which is the Brussels Human Robotics Research Center of the Vrije University, which brings together 8 different research groups striving to improve the quality of life and working conditions of people through human robotics. And as a little side note, BruBotics combines expertise in robotics, artificial intelligence, rehabilitation sciences, aging, eHealth, social sciences, and it is one of the only really interdisciplinary robotics research centers in Europe. And they are looking, together with their industrial partners, they are looking to take the next step in human robotics by breaking all sorts of different boundaries. Marwa is working to model and simulate self-healing soft materials for robotic applications. Her master's thesis focused on anti-stealth technologies for safe operation of unmanned aerial vehicles. Prior to these initiatives, Marwa was a research graduate at Twente University, a research engineer in Vrije, Illinois, Europe, a research scholar at Tartu Institute of Technology, and assistant lecturer in the Mechatronics and Industrial Robotics program at Mini University in Egypt. Marwa also hosts the Soft Robotics podcast, where she herself interviews various researchers from academia and industry involved in flexible robotics. She is listed on the 30 Women of Robotics that we all need to know about. And when she's not thinking about robotics, she likes designing dresses, reading, and drawing female characters. We'll get into that also. Marwa, thank you for taking the time out of your schedule to talk to us for a little while.
Thanks so much, Ira. It was such a pleasure to be in your podcast. Thank you so much. Thank you.
Well, thanks for being here. And, I'd like to, as we typically do, start off by just handing things over to you. If you could take a few minutes just to introduce yourself, a little bit of your background, where you grew up, how you got interested in science, engineering, and how sort of robotics became your thing.
Sure, yeah. So, thank you once again for being in the podcast. As you said, I grew up in Egypt, so I'm from the south, and it was a very simple life, and I never had anyone in the family who was engineer, and that was for me the first female engineer in the family, so it was a dream for me. I would like to tell something that when I was young, I was telling my late mother that I don't want to be an ordinary girl, just want to make a difference to the world. So I just was, as they say, a top student, which I don't believe in the system of being top student anymore. And I got employed as a senior assistant lecturer. Also, I love teaching, I love research, but I didn't enjoy it a lot. So I decided to pursue and travel to other opportunities outside of my home country. And along the way, I just found that I'm also passionate about podcasting. And that was also an old dream for me to do something. I would like maybe to define myself. I'm different in, I want to make something different, a way of thinking. I don't want to follow the norm maybe. That's maybe how I like to find. I'm so passionate, hardworking. So that's how I would like to call myself, yeah.
Wonderful. And when I look up, and I apologize ahead of time that I do not have a background in robotics, but when I look up this theme of soft robotics, it's sort of defined as this subfield that deals with constructing robots from materials and creating properties that are similar to those found in living organisms. Could you take us a little further into this theme of soft robotics and what it really means?
Yeah, sure. Yeah. Actually, what's interesting about soft robotics, because when I was working before, it was traditional robotics, everything from rigid material. And if you look about that, one of the issue, I think what we face in robotics now is an issue of safety. For example, the spot Boston Dynamics robot, if you have to interact with this robot, you have to take a precaution to meter distance to be in a safe position. But that's a question, even I asked it yesterday in the podcast with one of the members from Boston Dynamics, that do you think soft robotics could be incorporated in the design? Because that's something already in the mother nature. If you look everything, not everything, to be honest, we have the combination. I will give example for that. So if we look, for example, in starting, for example, from insects, for like a worm, for example, or octopus, a big example, these creatures are completely soft. And they have advantages. For example, they can maneuver in and goes through confined places. And that's something really, this is something fascinating. And if we go, for example, as we are human, we have both. We have hard or rigid element like bones, and also we have soft elements, the flesh and the fluid as well, blood. So we can see this could be a completely soft creature in the nature. And we have also hybrid, like us human and animals as well. We have this kind of combination. But while we think about soft robotics, the biggest example that I think is very good, everyone can relate to, is the artificial muscle. Even we are human, we have these muscles. But if we look at robotics, the biggest example, as I said, Boston Dynamics spot robot, for example, they have this kind of legged motion. But still what's the missing piece of that, how we can design something that's artificial muscle and soft and can interact. This is still challenging. So still we have this kind of rigid design. Of course, I'm not expert, I'm not saying you're expert, but is this based on interaction with the gestus? If the problem that we have, we still don't have artificial muscle that can give us the forces we need, for example. And that's why still, but of course we need that for the safety, for example. Of course, soft robotics, not all soft robotics are safe, and I can elaborate why, but still, yeah, we need to design artificial muscle that can mimic what we have in the nature already. But the struggle is how we can produce forces that we need. So far, we still have very little forces in soft robotics.
And continuing along that theme, because I saw, one of your main projects now is this artificial muscle actuator, and you're designing, once again, using soft robotics techniques. And I think in particular, I read about you were thinking sort of applications in surgical robotics, and that makes complete sense. That if you're doing a very complex task that you need sort of very fine dexterity, you don't want to the powerful robot that we think about wherever in the movies doing it. Can you talk about what the muscle actuator project is all about?
Yeah. Actually, this is not a new project. There was an attempt, I think, 10 years ago to the idea that, for example, in surgical application, how we can design, for example, this was a project about cochlear implants. So that's open problem. And yeah, many researchers was trying to work on that, how we can replace the passive material that the electrodes fabricated from with smart material that can sense if there is maybe buckling or forces, extra forces. And the issue or the problem is, I attended one of the surgery for cochlear implant. The problem is the surgeon, when they place this implant, they can't sense because they're wearing those gloves, for example, and they can't really, it needs a lot of dexterity that you know how you can place this cochlear implant correctly and not cause damage. And they can even use technique like MRI images during the surgery. So that's a limitation here. So that's why here there's a need for a smart material that can actuate and sense at the same time and tell you if there's extra forces produced or what kind of motion do you need to place this implant correctly. So it's challenging, of course, but still there's no something I can say 100% solution for it up to the moment. But still ongoing research. I love this project, but I think there are still people to continue to work on that. But that was a problem here, yeah.
There's several terms on your website that I'm completely unfamiliar with, but they sound really cool. Can you just tell what atomistic modeling is and how it relates to robotics?
Which one? I didn't hear.
Atomistic modeling. I don't know if I'm pronouncing that.
Atomistic, you mean like atoms,
right.
Modeling. Yeah, and the modeling, I think, again, I'm not expert because everyone say that. No, I'm not. I think what's really fun that when I started working, I'm really passionate about design and modeling. And the modeling, if people listening, they are levels for modeling. For example, you can have a physics-based modeling, so it's very complex. In the community, we can't go for that because we need still, for sake of simplicity, we need to maybe capture the most important parameter for designing your soft robot. And there's other techniques of modeling that maybe you don't have to consider fully the physics. You just consider like a gray area. So you're trying to make a simplistic model. And there's also black box modeling, which you don't know anything. The one I speak about this technique when I was in Tartu Institute of Technology, to use molecular dynamic simulation. And it's kind of physics-based modeling. So you go for, if we can imagine, we have the micro scale and micro and macro scale. So we have macro scale and micro and micro, the smallest one. So yeah, they go into the tiniest level, which is the micro, in molecular dynamic simulation. And of course, in soft robotics community in general, we don't consider that. And that's why, yeah, it's a minority working in this small scale of molecular dynamic simulation, very small. So yeah, it's just going to, it's just, I think it's more about related to chemical engineering, but I don't think it has, it's very complex, to be honest, for designing soft robotics. Yeah, it just, yeah, but it's fun to know, but it's very complex. Yeah.
Sure. Yeah, it sounds very complex.
Yeah.
It sounded like a cool term. In terms of other applications that you are quite interested in, you mentioned the original project with the muscle actuators, the surgical robotics, applications in human rehabilitation, human enhancement. Can you talk a little bit about sort of some of your ideas in that area in terms of, say, wearable type of robotic inventions, things of that nature?
Yeah, for example, I think, also, for example, one of the issues that we have to use, for example, this smart material is called ionic conductive polymer to actuate the fabric. So basically, that's the idea, that's one of points I was trying to work in, that how we can use this material to encapsulate or make this fabric actuate and sense. So that's what the idea, that how we can have a fabric that can sense you have like slouching or something. Mm-hmm. So you can sense if there is any forces produced or applied. So that was the idea behind it, to use ionic conductive polymer with the fabric. Yeah.
Very interesting. And moving obviously beyond the feel and the ability of once again a robot to be soft, let's say, in its activity. There's this theme that pops up a lot that we've seen in basically how a human interacts with something that looks like a robot versus something that looks like a person, and sort of this hybrid area in between. Are you doing much work in sort of how you're applying your knowledge in soft robotics to sort of what we're seeing in sort of the creation of like medical or social support robots that someone is good for interacting with, that doesn't look like a computer versus a person?
Yeah, for me, I didn't work in that. I have different experience working in that. But based on the guest I had in the podcast, for example, yeah, still the designing process that we can have something that can connect with the human. I think it's just far away. It's still a hybrid, to be honest. I can't say there's something, realistically speaking, we can call that you can interact with. So yeah, still, yeah, there's nothing. Yeah, I can't say about something. So because I did work, and still even didn't have solid result about that. So
yeah, no, it's still a bit out there, but I thought I'd you're very active in getting more women involved in robotics, and obviously across all STEM fields, this is something that a lot of people are pushing for. Talk about some of the initiatives that you've been involved in terms of spreading the excitement and the word about robotics globally, especially among women and young girls that want to get involved in this field.
Yeah, I think that's also just a duty for, I think, to try to outreach about how we can engage more women. But I think what's really interesting that I think I believe in now in inclusion as well. So I think it's not all about movement. So because we have to address many aspects of the robotics community. But I think for women in robotics is really interesting because I used to serve position in that before as a part of IEEE and also at Robotics Science System Conference. Yeah, I think when I speak to the women at the podcast, I think it's very inspiring when I see most of them serving as CTO, for example, or CEO. I had a couple of just podcasts. It's not published yet, but it is just fascinating. It does give us just the maybe inspiration that you have to prove yourself. However, to be honest with you, we still have unconscious bias in workplaces sometimes against women. Yeah, but yeah, we are trying to do our best, but still, yes, there's a lot of work to be done for women and also for underrepresented groups. Because yeah, I think that's something, yeah, still, I think we have a lot of effort to be more inclusive. We are diverse, but not inclusive fully yet, I think, yeah.
Got it. Any other big projects that you're working on at the university that aren't confidential, but that you're quite excited about that you can talk a little bit about in the coming things that are in the coming year or two that are really exciting for you?
Yeah, I think one of the really hot topics is about self-healing robots. I think there are a couple of groups, including mine and other groups, trying to work on that. And yeah, they say that I'm not allowed to speak because yeah, when you have this IV, I wish I can. I'm a big believer to have like open discussion, but yeah, you have to follow the rules sometimes. Yeah, but yeah, it's available and yeah, just what's self-healing and yeah, it's already in the nature. If we look in the nature for human or even animals, when they have losses, for example, yeah, if we speak for the lizard, we have an episode with Professor Talia Moore. She is designing for example, she's designing robot to understand biology. And this is very interesting. She's making the other way around. So she's designing robot to understand what's happening in the, for example, in lizard, how they locomote, and even we have a fascinating discussion about when they lose their tail or how they grow, and sometimes it affects the energy of their bodies after, yeah, they're losing their tail, and sometimes they not grow properly. So she's expert, and I really enjoyed this discussion with her about. Yeah, spoke about self-healing in nature. But again, I apologize because yeah, it is not about me. You can speak more detailed about, yeah, about projects. Yeah.
No, it's fine. But that alone, you know, thinking about self-healing robots, that's pretty, pretty wild. Just even think about the concept. So that's great. I'm glad you're working on these concepts. It actually just made me think of something, and I'll just I know these are not directly what you work on, but as you do run the podcast, I'd like to get your thoughts on just two things really fast in the robotics field. One, I know you did an episode recently on sort of tiny nano robots and things like that, which are, you know, continually thought of as one day, I don't know what 10 years, whatever we're talking about, you know, injecting in the human body to do stuff. Love to get your thoughts on that topic. And then secondly, another area, and as you were talking about animals now, there used to be, I haven't seen much on it in terms of sort of the reverse, basically the remote control animal. So instead of creating the robot snake, you would actually get a snake and put a little helmet on it and do, you know, so it could go places. Just love to get your thoughts on both of these futuristic areas in terms of the robotic space.
Yeah, maybe I can for the other one if you speak about like brain-computer interface. That's what you
right.
Yeah, because I used to work in that, but for the first part, I'm just if I'm going to speak about reflecting the guest experiences on the podcast. But maybe if we speak about the micro or just nano robotics, as you said,
Sure.
That's, I think, interesting. We have a couple of really great scientists in the podcast, like Metin City, for example. And we're also going to have Robert Wood. He's from Western Institute, and he's really a leader in this skill of design. But I think one of the issue that when I ask this question about what is the limitation when you go to the micro scale, all of them say that it's very complicated when you go from, for example, the bigger scale or continuum scale to the micro one for insect design, it is very challenging because I remember, for example, Metin said that I asked him what are the challenges when you design, because he is one of pioneer already. He's designing the tiniest micro robots. So when I ask him, everything is to become challenging. The energy, how you can make this system have this energy affecting, and yeah. So yeah, I think fabrication also one of issue when you go to scale, and how to control them. For example, Metin City is using magnetic control to control this micro-magnetic robots. So yeah, his project is very well known and you can check it. But yeah, I think one of the challenges is modeling them and considering these parameters, how they change into this small scale is super challenging. Yeah. And for the second part about, if I understood correctly, you mean if you can use brain-computer interface to control something? Is that what you mean?
Yeah, I mean, I think the original term for it used to actually be remote control animal, and the only, I mean, I know they did it with pigeons, and this, I think they tried it with a snake at one point, but instead of actually building the snake robot to go search for something, they actually used the snake and put a little helmet, brain computer wise. I know it's technically not robotics, but I just thought it's soft. I thought I'd ask you about it.
Yeah, to be honest, for example, in control, I think people know there's maybe RC control, which is used. It's something, it's not really autonomous. And for the brain-computer interface, if you mean that how I can control something with a thought of my head, if I understood correctly.
Yes.
Yeah, I have been working in EEG experiments, so it was really, to be honest, if we speak about how you can do that, for example, how you can do EEG experiment, you have this kind of stimulus. So for example, I want to turn this light off. Yeah. So I have this kind of visual stimulus, and there are many types of stimulus. For example, visual, auditory stimulus.
Yep.
And you train this kind of thoughts, and you see how the frequency of this thoughts, and you do that for like maybe the more events you had, for example, 1,000 times, you train it and you get this average, how the frequency of your thoughts for this action, whatever it is. So that's what's called a pattern. So you know the pattern here, when you have this frequency, you do this kind of action. So of course in EEG, I think, yeah, I love this field since 2014. But one of the challenges, for example, in EEG is that the signal sometimes is very noisy and they have a lot of artifacts. And there are many types for the sensor itself. It could be wet, for example, and it could be dry electrodes. So yeah, I think there are many details, but still, yeah, maybe, I don't know. I'm just curious about what Elon Musk is doing now for Neuralink. Still there's limitation, but maybe that's something, yeah, just interesting. Hopefully we can have something, but still, I think we're far beyond what we, think that, we can do right now. I think there's a lot of development, to be done. Yeah.
Well, maybe one day he'll tell the world what what he's up to there. But final question. Tell us about drawing the female characters. Is that a hobby of yours, and can you beat a robot doing it?
No, I think just have a robot drawing. I think that's something fascinating. But I think for me, I love drawing female characters in a few seconds, and I still doing that. It's just fulfilling for me to. I'm not calling myself like very talented, but yeah, I can draw them in very fast with all details and even design dresses because I love designing. So I can get different designing and different inspiration for hair design and dress and jewelry as well. So I really love that. So yeah, I'm still doing that, and I'm hopefully one day I can be in business of designing or anything. Hopefully, yeah.
Excellent. Well, it's a fascinating domain that you work in there, and really wishing you the best with it. For everybody that's going to be watching this particular episode or listening on the podcast, you've been listening to Marwa ElDiwiny at Vrije University in Brussels, Faculty of Applied Sciences in the Department of Mechanical Engineering, working on the BruBotics, Brussels Human Robotics Research Center, and all of their programs. Really exciting stuff. Marwa, thank you for for taking the time to talk to us and share your expertise and all this current and future stuff. And as we say, thank you for helping to create a better tomorrow, in this case through human robotic interactions.
Thank you.
It's been a pleasure. It's been a real pleasure.
Thank you. Thanks a lot. Thank you for your time. Thank you.